Problem 9. A plastic rod has been bent into a circle of radius r equal to 8.20 centimeter. It has the charge q1 which is equal to plus 7.07 picocoulomb uniformly distributed along 1/4 of its circumference, and the charge q2 equal to minus 6q1 uniformly distributed along the rest of the circumference. With v equal to 0 at infinity, we have to find what is the electric potential at the center of the circle. And the second question is, what is the electric potential at point P on the central axis of the circle at a distance d equal to 2.05 centimeter from the center? So actually here we have to answer two questions. What is given in the question? You have to take a plastic rod, and this plastic rod was bent into a circle shape, and that circle radius was given as 8.20 centimeter. And if you see this diagram, two different colors are mentioned. So here, this green color part, that means this is the circumference of the circle. So in the circumference of the circle, the charge q1, it's exactly occupied a quarter of circumference. And then the rest of the part was covered by a charge q2. So in a circumference, it was divided into two parts. That means in the quarter part, you have q1, and in the remaining rest of the parts, you have q2. Now what we have to do, based on this charge q1 and q2, we have to find what should be the electric potential at point C. That is our first question. And in second question, we have to consider the same charges q1 and q2, but in the second part, we are going to find what should be the potential at point P. That means from the center to a point, we have the distance value, which is 2.05 centimeter. So first part, we are going to find what should be the potential at point C for both charges q1 and q2. As we already studied in theory, we know the formula for potential, which is V, which is equal to K Q over R. This is the formula, right? And we have to use this formula for these two cases. So first, I'm going to answer the first part. Before that, let's write the given first. What is given in the question? They gave two charges. The charge q1 takes the value of plus 7.07 picofarad. What's the meaning for pico? Pico stands for 10 to the power of minus 12. So 7.07 multiply 10 to the power of minus 12, and unit is coulomb. And q2 charge is also given, which is minus 6 multiplied by q1. So that means we have to multiply minus 6 with q1 value. And also, when you bend the plastic rod, it forms a circle, and that circle radius was given, which is r is a distance from the center of the circle, or which is equal to 8.20 centimeter, and you have to convert this value to meter, which is 8.20 multiply 10 power minus 2 meter. And also they gave in the second part, we have to find what should be the potential at point P, and from the distance of the center of the circle to a point P, they gave the distance value caps D, which is equal to 2.05 centimeter, and you have to convert this to meter, which is 2.05 multiply 10 power minus 2 meter. Now we have to use this formula for these two charges. So in A part, what I'm going to do, I'm going to find the answer for the electric potential at point C for both charges q1 and q2. So I have to use that formula for both charges q1 and q2. So in part A, we are going to write the formula for net potential. So the net potential at point C. So we have to write the formula. So the net potential at point C, which is equal to K q1 over r. R is the distance from the center of the circle, plus we have to use the same formula for the second charge, which is K q2 over r, right? Now I can take, so better we can take the common term outside. If you take the common term outside, we will take K over r outside, and inside we have q1 plus q2, right? Now we have to substitute the value of q1 and q2. So I'm going to substitute the value of Q2 first, because why? The Q2 takes the value of minus 6 times of Q1. So by that we will get something. So what I'm going to do, in place of Q2, I'm going to substitute minus 6Q. So what you'll get, K over R, Q1 as it is, but in place of Q2, Q2 is minus 6 times of Q1. So I have to write plus of minus 6 Q1. So that means, which is equal to K over R Q1 minus 6 Q1, right? Now we have Q1 and Q1, so that means 1 Q1 minus 6 Q1. So that means we have K over R, inside the bracket we got minus 5 times of Q1. So we can take the minus out and we will substitute the value. Once we substitute the value, we will get the answer directly. So that means the potential at point C, which is equal to, in place of K, we have to use the value 8.99 multiplied 10 power 9 divided by, and R value is already given in the question. So I have to go back to the given. R value is 8.2 centimeter. 8.2 multiply 10 power minus 2 multiply by minus 5 multiply by Q1 is 7.07 picofarad, right? 7.07 multiply 10 power minus 12. So let's see what's the answer. 8.99 10 power plus 9 multiply minus 5 multiplied by 7.07 10 power minus 12 divided by 8.2 10 power minus 12. So I got the answer here as 8.38, but we have to mention the sign here. So minus 3.88 and the unit is volt. So this is the answer for the first part. Clear? Okay. Now we have to find the answer for the second part. What is given in the second part? In second part, what we are going to find? We are going to find the net potential at point P, right? So again, we have to use the same formula, but this time the main thing, from the circumference to the point P, we have to find the distance. What's the distance here? The distance of this line is square root of R square plus D square. Clear? And now the distance is this one, and we have to find what is the net potential here. So what we have to do, we have to apply the same rule. So net potential at point P, which is equal to K Q1 over the distance from the circumference to this point P is this one, square root of R square plus D square plus K Q2 over square root of R square plus D square. Now I'm going to take the common term outside, so which is K over root of R square plus D square, and inside the bracket we had Q1 plus Q2, right? As we know, Q2, which is equal to minus 6 times of Q1, which is already given in the question. So I have to substitute the value of Q2 here. K over root of R square plus D square, inside the bracket Q1 plus minus of 6 Q1. Again, we will get minus 5 Q1 if you simplify this part, right? So K over square root of R square plus D square minus 5 times of Q1. Now I am going to substitute the value. All the values are given in the question. The value of k is a constant value, which is 8.99 multiplied 10 power 9 divided by R value is already given in the question as 8.2 centimeter. If you want, you can go back to the question and see the given. So the value of R they mentioned in the question as 8.2 centimeter, but we have to use the meter value, and also the distance value is given in the question as 2.05 centimeter. 2.05 centimeter. So we have to use this meter value. So I have to substitute the value. So 8.2 multiplied 10 power minus 2 the whole square plus d value is 2.05 multiply 10 power minus 2 the whole square. We have to extend the square root, right? Multiply by minus 5 multiply with q1, which is 7.07 picofarad. So 7.07 multiply 10 power minus 12. So now we have to find what's the answer for the net potential at point P. Once you got the answer, that's the answer for the second part. So here I have to substitute the value. Let's see what will be the answer. 8.99 10 power 9 multiplied by minus 5 multiplied by 7.07 10 power minus 12 divided by square root of 8.2 10 to the power of minus 2 square plus 2.05 10 power of minus 2 square. I got the answer here as minus 3.76 volt. So this is the answer for part B. That's it. Thank you.